Hey there, so if you're working in Python, you're probably a pro with lists. I mean, they're everywhere, right? They're super flexible, really powerful. But what happens when you need more? When your data has to follow certain rules? Well, today, we're going to unlock two of Python's secret weapons that go way beyond the list: tuples and sets. Okay, let's get into it.
Just think about it for a second. A list lets you do pretty much anything. Add stuff, remove stuff, change stuff whenever you feel like it. And that flexibility is awesome. But sometimes it's actually a problem. What if you're storing data that you need to make sure never, ever changes? Or what if you have a huge collection of items and you absolutely cannot have any duplicates? A regular old list just can't enforce those rules for you.
So, in this explainer, we're going to dive into the two specialized tools that Python gives us to solve these exact kinds of problems. It's time to go beyond the list and find the perfect tool for the job.
First up, let's talk about the tuple. Imagine for a sec that you're storing something really critical, like, say, the XYZ coordinates for a 3D model, or maybe a user's permanent record from a database. You need a container that's going to act like a guardian, something that protects that data from ever being changed by accident. Well, that guardian is the tuple.
The two most important words in that definition are ordered and unchangeable, or as programmers like to say, immutable. And honestly, the best way to think about a tuple is like an engraved stone tablet. Once you carve that data in, that's it. It's there for good. You can look at it a million times, but you can't just scratch something out or add new carvings later.
So here's the deal. A tuple is ordered just like a list, which means you can grab items by their index number. It also allows for duplicate items. But its defining superpower, the one thing that really sets it apart, is that it's immutable. That's the trade-off, right? You give up the ability to change it, but in return, you get rock-solid data integrity and safety.
All right, time for our first challenge. Take a look at this line of code. We're making a variable x, and we're setting it to 5. So, what data type do you think x is? It's wrapped in parentheses, so it's got to be a tuple, right? Go ahead, pause and take a guess, because this is a classic Python gotcha that trips up a lot of people.
And the answer is, it's an integer. Kind of weird, right? Here's why. In math, we use parentheses for order of operations, and Python respects that, so it just sees the number 5. If you want to tell Python, hey, I'm serious, this is a tuple that just happens to have one item, you have to add a trailing comma. It looks a little funny, but that little comma makes all the difference. So, x equals 5 comma is a tuple. X equals 5 is just an integer.
So you may be wondering, how do you even work with something you can't change? Well, the trick is, you don't modify tuples. You create new ones from pieces of the old ones. Let's say we start with this tuple, t. If we want to get rid of that first element, we can't just delete it. Instead, we use a slice, t to 1 slash, to create a brand new tuple that has everything except for that first element. The original tuple t is still there, completely untouched.
Okay, let's kick it up a notch. Slicing can get really cool when you chain operations together. Check out this code. We're doing 2 slice operations, one right after the other. What do you think the final result is going to be?
Let's break this down. Python just works through these chains one step at a time. First, it sees nums//2. That goes through the tuple and grabs every second element, which gives us a new temporary tuple, 10, 30, 50. Then, it applies the second slice, //1, to that new tuple. And that slice is a classic trick for reversing something. So, it reverses 10, 30, 50 and gives us our final answer, 50, 30, 10. Pretty neat, huh?
All right, so that's the tuple, our data guardian. But what about that other problem we mentioned? What if you need a collection where you only want unique items, and you couldn't care less about what order they're in? Well, for that job, we bring out our second secret weapon, the set.
So a set is an unordered, mutable collection of unique elements. And the analogy here is just perfect. Think of a bag of Scrabble tiles. Each letter tile in that bag is totally unique, right? You don't have 2 identical Q tiles, and when you reach in to grab one, there's no telling which one you'll get. That's a set in a nutshell. All unique items, no particular order.
So let's break that down. Unordered means you can't ask for the first item or the third item because there is no first or third. Unique means if you try to add something that's already in there, Python just ignores you. Nothing happens. And unlike a tuple, a set is mutable. You can totally add and remove items, and you'll spot them by their curly braces.
Okay, quiz time again. Now, sets can hold different data types, just like lists and tuples. But what do you think happens if we try to put a list inside of a set? What if we try to run this piece of code right here? You think that'll work?
And nope, your program is going to crash with a type error. And the reason gets to the very heart of how sets work. To be super fast at checking for duplicates, a set requires that its elements are hashable. Now that's just a fancy way of saying they have to be immutable. They can't change. Since a list can be changed any time, it's not allowed in a set. But numbers, strings, and our old buddy the tuple, they're all immutable, so they're welcome in a set anytime.
Now, just storing unique items is pretty useful on its own, but the real power of sets, the reason they are so amazing, comes from their ability to perform mathematical operations. This is where they become like data analysis superpowers, letting you compare huge collections of data with just a single line of code.
These 4 operations are incredibly powerful. Take intersection, for example. Let's say you have a set of all the customers who bought a laptop and another set of customers who bought a printer. The intersection of those 2 sets instantly gives you a new set of only the customers who bought both. Or what about difference? If you have a set of all your employees and another set of employees who finished their training, the difference instantly tells you who still needs to get it done. This is why sets are an absolute game changer for data analysis.
So we've met the unchangeable tuple and the unique set. They're both incredibly powerful, but they're very different tools. The final piece of the puzzle is knowing exactly when to pull each one out of your Python toolbox.
Honestly, the choice boils down to 2 key questions. Does the order matter, and can the data change? You should reach for a tuple whenever the order of your items is critical and you need to guarantee the data will never be modified. Think coordinates or records from a database. On the other hand, you should use a set when all you care about is uniqueness and being able to do lightning-fast checks to see if something is in your collection, like finding all the unique tags on a blog or managing a list of user IDs.
And as we wrap this up, I think this quote from the great B.B. King is just perfect. You've just added 2 really powerful new tools to your programming toolkit, and that knowledge, that understanding is now yours to keep and build on forever.
So I'm going to leave you with this final thought. Now that you know how to enforce immutability with tuples and how to guarantee uniqueness with sets, what new doors does that open up for you in your own projects? What problem that seemed kind of tricky before now has a really clear, elegant solution? Happy coding!